Another investigation we conducted as part of the study was looking into priorities for projects, especially when it comes to choosing whether to prioritize heating and cooling. And we did that because in our conversations with builders that we train and we provide consulting for, there's a misconception, especially when it comes to warm climates, about the importance of heating, even if it is a hot region like California or Texas. And I'm very familiar with that. I'm from northern Italy. Italy, you may think of a warm climate, but it's actually very predominantly heating dominated as a climate. So in carrying out this big study over 50 different projects in different climate zones, we also try to compare what benefits do we get from passive house in reducing heating and what is the impact on cooling, and vice versa. If I improve the cooling, what is the impact on heating? Because sometimes prioritizing one over the other causes the other to become worse. So more insulation, more air sealing, higher performance windows, etc. Sometimes cause a building to perform better, cause the building to perform better for heating, but sometimes results in some higher cooling demand. So we want to look at that. Is it really worth it? Then, so we looked at the site energy for heating and cooling combined for buildings. We used, in this case, as the baseline, buildings built to the draft of the 2024 IECC code, and we compared their performance for heating and cooling with the same buildings designed to meet passive house. Over the project considered the reduction of heating demand with passive house techniques, grade was much, much better compared to the small amount in cooling caused by the same measurements. This is what we're talking about. So we compare PHI passive house with the draft of the 2024 International Energy Conservation Code. In this graph, we see gray columns. The gray columns is the site energy consumption for the building for heating for buildings built to the 2024 energy code, and in orange, much smaller, the same buildings but built to passive house. And this you see at the very bottom numbers from 1 to 49, actually to 50. Those are the individual 50 projects that we included in this study. Now, when it comes to, you can see that the yellow is very much smaller than the gray columns because passive house makes buildings so much better in reducing the need for heating. Now, looking at the need for cooling, in this graph you see a few things. All the columns are much smaller. And keep in mind that of these 50 projects, we have, I think, 14 in warm climates. So even for those 14 projects, the need for that are located in warm climate, California, Texas, and Florida specifically, the need for cooling is less than the need for heating. And you can see on the right hand side, you can see for a few projects, you can see that the yellow column is a tiny little bit taller than the gray column, meaning that the project for those few projects, if we use passive house, the need for cooling is going to be a slightly little bit greater than if we stuck to the energy code minimum, but the reduction of heating and the reduction of energy overall is definitely in favor of passive house techniques, including air sealing, insulating, high performance windows, and so on. On top of that, please keep in mind that in life, heat pumps perform much better in providing cooling than providing heating. We're going to see more of that later in these videos. But if you're trying to use, whatever generator you're using, they're going to perform better in tackling the cooling as opposed to in tackling the heating. So the less heating need you have because your building is better, the more efficient it's going to be. Also, cooling happens at the same time when the sun is shining, basically. and then when the sun is shining, you can have on-site renewable production, meaning that your PV system, your photovoltaic system, is producing at the same time as your cooling system is going. So you don't really need to exchange with the grid. You can consume your own energy. Whereas heating is coldest typically at night. There's no sun shining at night, so you need to take that energy from the grid. So these are two more considerations upon which we base our typical recommendation to give priority to heating efficiency, even in warm climates, because it's very important, and there's several things that favor cooling. So it's important to give priority to heating efficiency.